All the tools that you kind of need. We'll look at the gauges to begin with. Normally use some analog gauges as opposed to digital. In work you might have something fancy. These are just 2-port. So what I tend to do is just shut that down. Do you know how these gauges work? Yes, no?
Please explain.
Oh, we'll explain.
Well,
Right.
you know
Okay,
what to
right. You got 3 hoses. Now, you never want that scenario where the hoses are on the floor. On the floor, you've got dust, dirt, potentially puddle of water, and that's when you get in the gauges. So it's always up off the ground. It's just best practice to keep it off. Right. You've got red gauge, blue gauge, red friend, blue friend. All right. And you can just open or shut them. Whatever's in the red hose, irrespective of that position, is reflected in that red gauge. Same with the blue. Whatever's in the blue is in there. All these do is connect the red to the yellow or the blue to the yellow, just by opening it. All right. And you'll hear me say, as you do the practice, if the gate's shut, nothing can go through. So if it's shut, that is isolated. If I want to join these two together, I open that one. If I want to join these two together, I open that one. If they're both open, all 3 are open to each other. Happy with that? Mm-hmm. So the red and blue generally going to go on the system. The yellow is more of a utility type hose. And the yellow hose we will use for things like backing out, charging, going onto the bottle, bit of recovery, etc. So gassing it out. These got rubber hoses in there. There are other ones with like a more of a plastic type, but just make sure they're in reasonable condition before you put them on. I have more problems here with sort of hoses than anything else. And we've got this shut off. If I shut that, that isolates here, but obviously this bit is open to, in this case, atmosphere. So if I put anything in this red line, shut in there, red line's trapped, but that's open to, in this case, that would be the air. Does that make sense? Same with the yellow. So we're going to use these valves quite a lot because we can sort of isolate and do things with this to get the gauges off and minimise loss of refrigerant. You've got to think about today, you don't want to put air in with the gas. Air is the enemy because it contains
moisture,
which will create acid, which is going to eat away at your windings and give you sort of burnouts and stuff like that. And can you imagine changing a compressor is not going to be cheap. These got these little pop-out things here. If you take them out to screw behind, so it's not on 0, you can adjust that screw and that will move that needle to go there. You can get digital versions, but for today and what we're going to use, the analog's going to be absolutely fine. You can also get ones with 4 sort of valves on, and that means you can just shut a hose off for vac and 1 for charging, so you can have like 1 up to a vac pump, 1 to your bottle, 2 on the system, and then you don't have to disconnect hoses each time. So you might see different companies working different time. Come to the system. And you know, if you look at the notes I've given you, the first thing is let's get the gauges on, and then we're going to vac out, yeah, and then we're going to charge, and then we're going to remove the gauges and put the gauges back on. That's quite complicated, and then we're going to recover, which is also fairly complicated. So it's more like the gauges on, gauges off, and the recovery that tends to trip people up. So hopefully the video will give you a bit of insight on how to do it. So you can ask any questions, you can make as many notes as you want. And also we're going to get gauges on because I don't know what's in there. If it's full of gas, I can't back it out. I've got to get rid of the gas first. All right. So there might well be a little bit of nitrogen in the systems, how they left, or they might be left on the back. That tends to be how we leave them. If you put some gauges on and there's pressure in it, it will not be refrigerant at this stage. All right. And at the end of today, you need to leave them sort of gas empty, so we're ready for tomorrow. So we can't leave it gassed up. There will be times backing out and recovery. You're waiting for the machines to do the job, so not a lot you can do, just monitor the system. If you want to break at any time, when it's backing is a good time, because backing is the bit that takes us on. So once we got on back, well, it's going to take sort of quarter an hour to get down to where we need it to be. Does that make sense? So you can go and have a cup of tea, use the toilet, make a phone call. But what I don't want you to do is have a run through, stop, go and have a break, then come back, get your gauge on and vac out where you stood around for another 10 or 15. It does happen, but vacuum is the time. All right, so you can have breaks anytime you want, lunch anytime you want, but just make sure it's on back when you do that, because that's the bit that will take the time. Are you all with me at the moment? Okay, so tools just to the right. sort of adjustables, and we've got this service ratchet, which I'll explain when we come to use that. So that is for this type of valve. Got some gloves and spectacles, and in a minute we'll get a grass bottle out and stuff like that. But first of all, let's see if there's any gas in. Now, on here I've got 3 access points. This is my discharge, the small pipe. Suction is the big pipe, and you see the suction has the insulation on, although it's not missing here because of what we've got to do. And if you look at the black one, suction has the insulation, discharge doesn't. Suction is always the bigger pipe. We've also got a valve on the liquid receiver, which is here, and that's where we're going to be fitting our high gauge today, because we're going to be vacuuming out and charging, and obviously I want to be charging into liquid receiver. If you've got a system that hasn't got a thing, you might just be charging into the discharge and it will go around. It depends on the access points that you've got on the system. Any questions on that? Right, so on this one, we're going to take this off. They shouldn't be that tight, and they are only plastic, so when you put them on, they don't need, you don't need to be He-Man here, Arnold Schwarzenegger doing them up. They just have to be just over hand tight. Got this stem that sticks out. That appears to be in the back seat position, would we agree? Well, it appears to be quite far out, yeah. But we need to check it. So I'm going to put this on, and it feels like it is tight, but we'll edit that bit out. I need to make sure this cap is tight, because what I'm going to do, just to make sure it's back seated, and you guys sort of have an understanding the mechanical background and stuff like that, the valves can seize. We're just going to crack it in, then I'm going to flick that, so you can see I'm just flicking that lever, and then just go back. But it is almost just a stiff 2-finger tight. Does that make sense? And that will be fine. As you can see, got 2 ports. It's only the one closest to stem you can control, which is important on this one, because can you see this one's got 2? Yep. So it's only
the one closest to the stem.
And if you look at the black one on top of the receiver, there are 2 there. Which one is closest to the stem?
The one on the side.
The one on the back. So that is important. So I'm going to do the same with this one. And again, feels like he's back seated, but I'm just going to crack him in like so. Flick the ratchet, and again 2-finger nice and tight to make sure he's back. Now we're going to fit gauges on now. I don't know what's in the system, which involves me removing the cap, so at this stage unfortunately it will be the PPE on. PPE will be potentially difficult for you to do parts of the job, so if you want to take it off at any time, that is fine, but if it needs to be on for a certain task, then it needs to be on. So you've got to think when you're handling refrigerant, or potentially handling refrigerant, when you're handling nitrogen, that's when you're going to need your gloves and goggles on. Pressure testing is another. Alright, we've got different types of gloves, so these are like the disposable type. We've got other ones around there, and I think some of you said you bought your own in as well, so we'll look at those. Right, I can now remove my cap. If there is a hiss, because I've cracked it in and back seated, it might have filled a little bit of gas up, but it's literally just going to be a cap full. But if I hadn't done that and that was slightly cracked in and seized, I wouldn't know. In which case I would do this and I'd be losing a lot more gas.
So that back seat at the moment is stopping anything coming out?
Yes, it's stopped off there, so that and that are all connected, but this one is it isolates that one. You can only remove this cap if it is in the back seat position. It cannot be any other position. If it's front seat or mid seat, you can have a lot of gas, a lot of oil come out, and you're going to be in a world of trouble.
Yeah.
You've got to think about your cool bands and stuff like that as well. Take the cap off. So, blue is the low side. Blue begins with what there?
Big.
And the big pipe begins with?
Big.
Blue pipe on the?
Low side.
Big pipe. Low side, but it is a low side, yes. Right. Get the blue gauge onto here. And when you've got it, this needs to be tight. So if you hold it and then just move the whole thing together, and the whole thing together, and I do it so it's nice and tight. If there's any wobble in there, if it wobbles, air can get in, and you'll know when you come to back out. So just hold that, but move the whole thing, and the whole thing turns, and that but if you just have a feel, nice and tight. If I go the other way, can you feel? You can literally hear the wobble.
Yeah.
So you've got to give it this test. Make sure it does not wobble. Make sure it is tight. Refrigerant or air will go through the smallest of holes. So if you're vacuuming out, you'd be dragging air in. If you're charging refrigerant, refrigerant's going to be coming out that gap. Happy with that one? Okay, do the same with the red. But what is in my red hose at the moment? Air, which we know is the enemy. Yeah, we don't like air.
Look at the angles, Harry.
Under pressure now, he's videoing me. So again, just twisting the hole, lock together, making sure he's on nice and steady. I'm going to make sure my frames are shut at this stage. And I'm just going to hook it. I'll get the yellow one out. So I'm just going to hook it on here so we can all potentially see the gauges. So when I open up, we're going to see if there's anything in there. So to open it up, I need to remove this from the back seat position. I'm just going to crack it in. I'm just going to give it sort of 4/4 turns. That will just remove it off the back seat, and it will be more than enough for what we need to do today. I should also explain there are different ones on here, all different sizes. So there are potentially 4 different size stems depending on what size system you're going to be using. So we'll put this on. It says, I'll go the right way. So how many turns does it say?
4.
4. So just about 1, 2, 3, 4. If I look at my blue gauge, can you see it's literally gone into a vacuum, so there's no gas in here. It's just the way we leave it. So once you guys are finished, next time Simon's in, he'll vac the systems out to remove any air and moisture. It just protects things like the dryer and stuff like that. I'm going to do the same with my liquid receiver. Bring them on. 1, 2, 3, 4. That's it. Gauges are still shut, so remember whatever's in the red hose is in there, whatever is in the blue hose is there.
Oh, okay, so the gauge is only opening up to the yellow line.
It's up to the yellow line, yeah.
Yeah, so it'll always show on the gauge.
Yeah. Now, if this was a running system, I would have vacuumed my gauge lines out before cracking it in. But because I know there's no refrigerant in there, I didn't need to do that. But when I take the gauges off and on, we'll be vacuuming the gauge lines out at that stage. All right, but if I wasn't sure whether there was gas in here or not, I would have vacuumed them out, because if there was refrigerant, it would have now mixed with the air in my hoses, and that would be bad. So in the work, they might just do a purge, or they might just crack that in. This will come up to a reasonable reading. They'll crack that, you get a hiss, and they'll stop it, so that's purging it. That way they do the same with the blue, but as soon as I open these, there's a big bit of air in this yellow bit. All right, and even if I even if I purge it, I'm not guaranteed to get rid of all of the air. The reason I didn't do that is because I know kind of where it is at the moment and what we're going to do next. Okay, any questions on that? So give myself a thumbs up at that, so I know when I go to edit it, I can stop it there and then move on to the next bit. All right, I really need an action.
Clipperboard.
Action.
Clackerboard.
Thumbs up.
Action.
Thumbs up.
Right. So when I see the thumbs up, I can just go on the cap car thing I've got. I can just go that and stop it there. So I've got one to fit the gauges, do off the back and out. So I'm going to try and break it down into.
Do you want me to stop it and start it for each one?
No.
Just leave it as one big.
Just leave it as one big one, and I can trim it down. Yeah, I think if we do that and you forget to start it again, then I can see that happening. Any questions on the gauges?
No.
All right.
And in this process, the red and blue fan are still closed, aren't they?
They're closed?
Yeah.
Yep, because if they're open and there's gas in, it's going to fill up my yellow hose, and then I've got to deal with that. So, a couple of things. We don't want air and moisture in the system, and we want the minimum, and I'm going to use the word minimal amount of refrigerant going into atmosphere every run through. We know, first of all, I want to go that refrigerant is expensive. So the more you release to atmosphere, the more it costs Channy. All right. Second of all, potentially dangerous to yourself, skin burns. We'd have to let a lot go in here to asphyxiate you, wouldn't we? All right, more than I could afford, but just bear that in mind. But when we're letting nitrogen go, we'll have the roller shutter door open and stuff like that, because ventilation will be an issue at that stage. And further of all, don't forget, refrigerant is bad for the environment. Where you're going to use 449A, it's kind of a medium sort of GWP gas, you know, when about 13, just under the 1400, but it's still quite high compared to CO2, isn't it? But a lot lower than things like 404A, which is just under 4000. And you're going to run through this as many times as you can today, so you're going to, a little bit here and there, it will all add up, unfortunately, at the end of the day. Okay, happy with that?
Yeah.
Right, next step is to vac the system out, so you're going to get a vac pump. And there will be a few differences. Well, there'll be one difference on this type of vac pump compared to what you know, say. Vacuum pump, fairly decent size. Can you see it's got oil in there? It's above the minimum and it looks quite clean. So that is one thing to check. Yellow gauge just goes onto the vac pump. So the yellow gauge, just going to bring that down onto here. But remember, the yellow is a utility, so anything you do in external is literally going to be through that yellow. This one's got a thingy missing, but it will be okay. Now, on your notes, it will say something about a gas ballast. And if I bring this one out, can you see this one here has a gas ballast, which is that? Clearly marked gas ballast. So when you use this one, you would crack that open, and then you would vac, and then when this comes down to about minus a third of a bar, and it's below that already, you would shut the gas ballast. And if you've got any positive pressure, it goes out through that gas ballast. This one hasn't got it because it uses a solenoid type thing. All right, so there's no gas ballast on this one, so you haven't got to worry about it for this type. If you've got the gas ballast, if you don't forget to open it, it's not the end of the world. But if you do open it, remember to shut it, because if you open it, you're not going to be in full vac mode. And if you don't open it, it shouldn't really be the end of the world, but opening it extends the life of your the working life of the vac pump. It just gives it a little bit easier at the start. So if there's any positive pressure, it's jettisoned before it goes through the vacuum chambers. So it's just a device saving kind of thing. So some of them have it. A lot of the new ones don't, because they use the solenoids instead. Obviously it needs electricity, so it needs to be on. Switch out the back, on, off. Alright, so it comes on. And at the moment I'm just literally backing out that little bit there because this is shut. If I open this, hear it change noise, and then it goes dull again. So once it changes noise, that's the air coming out. On this one, I'm going to open these two, and you can hear the change. Right, and you can see it's gone down quite far already, but it was left in the vacuum. The other two might have, the ones down the end, I'm pretty sure are in the vacuum. The black ones might have a bit of nitrogen, and they might have a vacuum. But when you get the gauge on, we'll have a look at that stage. Vacuum, what am I trying to achieve?
Too tall.
Too tall or
2000
microns. 2000 microns. So I'm going to need a tool gauge. So I'm just going to use tester one here, or the JVAC ones there, the ones that we tend to use here. They're kind of all right. Now, I have to fit my tool gauge somewhere. The ideal place will be as far away from that vac pump as you can get it. So ideally, remember this could be 20 metres away, and it goes in that side. So the far side of the evaporator would be the perfect place to fit that. But I've got no access points up here. I've got an access point here, which is literally half a metre away from there. Or I can go onto the discharge, which is the other side of the condenser. So I'm going to fit it on the discharge, just because that's as far away as I can get on this. Now the units you have in work, you might have access points down by the evaporator, and that would be the better place to fit it in. Same thing on here though. Make sure the cap's done up tight, because what have I got to do to this valve? Back it off. Make sure he's absolutely back seated. So again, on, crack it in, and nice and tight with the two fingers. And again, just making sure, twist the hole up, nice and tight on there. I can open that one. I'm going to switch the vac, switch the vac gauge on. Got a line. Just pass me that one.
What one? Sorry?
The one that's saying it. Yeah. Just take the yellow hose off.
If you
Maybe this up before you start packing it.
It doesn't matter, you know. Now, sometimes, can you have a look at that one, Si? Just not switching on, might need some batteries. Sometimes with fridge, it's a bit like sat nav. Some people got Garmin, some people got TomTom. Want to go left, want to go right, but if you get to the destination safely, doesn't matter if you go left or right. I like to get this on because I know I want to get the majority of the air out. But if you want to put this on and then put it on back, that's absolutely fine also. It's just a bit time consuming, so I like to get it up and running, get some stuff good. So I've got these things, zeros, which just basically tells me that atmospheric conditions. I will now open that, crack this in. Just the 4 sounds, and as you can see, nothing there at the moment. He's jumped down to 10 torque. So because it's been on a while, it's down to sort of 10 torque already. And all it is now is a waiting game to see what happens. Any questions? You should be able to pick this bit up quite easily.
What part was ensuring solenoid coil was open?
We will do that now. Can you see the solenoid is on? And that is shut. So at the moment, I'm backing up to both sides. If my TEV is shut, between there and the TEV, I'm going to have a restricted or dead leg. So we need to force it open with a magnet. So all you've got to do, undo this one. Pull that off, and we'll put that on there for a minute. Are you aware of what happens to a solenoid if they're energized and nothing's in the middle? Okay. Magnet opens it. Now, at this temperature, this TV is going to be fully open anyway, so it wouldn't have made any difference. It won't make any difference to our vacuum, but in work you've got to do that. If you energise a solenoid and there's nothing in the middle, that is what will happen to the inside. Nice. So that's what it should be like. That took about 7 to 10 seconds for it to melt. And if you can just put it on that stud, it's only going to be an issue if you energise with nothing in. What you find engineers doing is taking it off and whacking a big screwdriver down, or taking this off because it's just a screw to put on. Because batteries. Cheers, mate. Thank you.
Batteries turned up.
They did, yeah.
Yeah.
Okay, right. So that one's the same. This one, he just goes off. It goes on. There should be a screw in the end. So you think whoever takes a screw out and put the screw back in, don't you? It don't happen. And there is something wrong with our floor. It looks just like a floor, doesn't it? If you drop something on the floor, you'll never see it again. I reckon Simon done that with his wallet because we've never seen that one.
Never seen it.
Yeah. Right, scales. Make sure they're nice and steady on the floor. They do have, some of them have adjusted, this one doesn't, but some of them you can adjust the height with that, alright? So when you go, if you just want to keep all your boxes together, so you know that where it all kind of goes back. We're going to use sort of recovered refrigerant. Simon's got them sort of marked up 6 kilos and 4 kilos and stuff like that, but that's still. So we're going to not use virgin refrigerant, we're going to use recovered gas air, do it. So in and out the same bottle all day, as opposed to use new ones. So we try and reuse it as much as we can. We've got 2 bottles. types of bottle. Can you see one's got 2 ports, one's only got 1? This one, the single one, is the same as the blue one on here. Alright, so it's exactly the same as the blue one. The red one is liquid, the blue is vapour. So if I were to open that up now, vapour will come out. If I want liquid for this one, I have to turn the bottle upside down. So remember, the bottom of the classroom will push the bottom, comes out. When I finish backing out, and you can see we are below 2 torr already, which is good. Yeah, 1.6. But when I take this off, if I shut this, can you see there's going to be a bit of air in here? And I don't want to put air in my system, so I'm going to try and remove that air. And the only way I can do that is by purging very gently. And it's better to purge with vapour than liquid, because vapour is a lot less dense, so you actually will, potentially with liquid, depends on conditions, but liquid could be up to 60 times more dense, roughly, than vapour. So if I purge with, 2 centimetres of liquid, that could be 120 centimetres of vapour, just to put that in comparison. So we're going to purge the vapour, then turn the bottle upside down the jars. Is that okay? But I need to know, or you will need to know, how much gas is in there. Can you see this bit that says TARE, T-A-R-E? Okay, and we've got a 7.41 and 7.84. The way it works with these bottles, 7.41 is the bottle, 7.84 is the bottle plus the bulbs, and it's when they're empty they are 7.84, or it's been restocked to 7.84. They might change the bulb from a single bulb to a double bulb or something like that at some stage. So 7.84 is when it's empty. Maximum fill on these is 9. So 16.84 is the maximum this bottle could be. Cannot exceed that. Does that make sense? Yeah. Okay. When we go on to 13.9. So we'll use a calculator. 13.9 minus 7.84. Just under 6, or just over 6. Yeah.
13.9 minus 7.84. 6106.
Okay, so if I wanted to put 7 kilos in the system, I haven't got. If I wanted to recover 4 kilos into this bottle, I couldn't do that because that would take it over the 9 as well. So it works both ways. Is first of all, have I got enough gas to do what I want? Yes. Have I got enough space to recover what I want? Depends on the system. And if you guys dealing with 100 kilos, you're going to have bottles that are a lot bigger than this. Yeah, a lot heavier.
I think 5 or 6.
And they'll be taking bottle after bottle after bottle. Are you happy right away the bottle? It's one of the things you have to tell me tomorrow, how much is in there, or how much more could go in there. You probably only do that 2 or 3 times before you think, actually I've got that. Alright, torr reading. 1.4 torr. 1.47. Well below 2, yeah? On a steam table here. And a thermometer. The thermometer says it's 18.8, yes? I call it 19 because it's full. At 19 degrees, water will boil at 16 torr. And we're well below that. Yeah. Okay. So we are well below the 0.01, we're at 2. And it does tell you on here that at 1.4 torr, that water boils at minus 35. Let's get the... There we go, water boils. That's the air temperature, it's saying there 22, and water's boiling at minus 13.7, so we're well above what we need. You can change the mode, so for you guys...
So just ask a silly question. You were talking in water tones there, but how are you looking at it on a cooking?
Yeah. Sorry about that.
Because of
Right, so you can set that to microns for yourself. So if you want to change it to microns, you can do. So if you're used to using microns, use microns, it doesn't make any difference. But what I'm saying is, water at 19 degrees boils at, basically 16 degrees. At 19 degrees it will boil at 16 and 12, will well below that. You can see our boiling point is minus 14. It's 20 degrees in here. So if you go minus 14 to 20, that's 34 degrees. So it's like having steam at 134 degrees. So that shows you how dry it can be inside. So though F-gas stays below 2 torr, realistically it can be depending on the temperature and the torr scale. Warmer days it's going to back out faster, colder days not, you rely on the heat around the pipe right to make it boil, so colder days less heat, slower dehydration. But we're happy that's down to well below what we're asking for on the F-gas,
So 2 or below Raymond.
2 or below. So the next thing is I want to remove the torr gauge. To do that, I see I'm leaving the back pump running. So just let that seat. Nice and tight. I can remove, if I shut that off, it seals the torr in there a little bit. Take it up, but it doesn't matter too much. If I open that up, you see it should potentially go back to the atmosphere. Alright, so it doesn't matter if you get air in that one too much.
Again, we can leave that on till the very end and shut it down.
Yeah, no, you need to take it off before charging, because if you make a mistake, you don't want to be putting a positive pressure in there. Also, I never want to see a system like this with open. These are, as we talked about yesterday, leakage points. As are these, so I want a cap on here and a cap on here. Yep. But not only on, done up. When you do these, hand tight, spanner, just a nip. That's all you've got to do, just so you can. Some people are strong in those, you'll still be able to do it and do it by hand, but it needs to be quite tight. But if you over tighten it, it's just plastic. You'll strip the thread, yes? On this one, can you see this one is longer than this one? This one has a longer stem. Yeah? If I put this cap on there, what do you think will happen? The stem will come through the end and you'll end up with, can you see this one just on the end here? There's a little, where it's cracked. So someone's put that on that stem and it's just gone through it. So just be careful what stem, just make sure you put the right cap on the right one, don't over tighten them. Right, I want to seal the vacuum in the system, so remember we always go friends first, yes? Shut the friends. Shut this, that will seal my vacuum in that hose. Turn them off. Take that off. And just put the cap back on. Now give myself a thumbs up because I know then I've got the pause at that stage. So that's the back inside done. So we've got the gauge on and we've got it back. Didn't take very long to back. They might take a bit longer when you do it. And they're frustrating units sometimes. Sometimes they'll back down really quick, other times they will really struggle. And if they struggle, it's normally to do with one of these or that little collar that you've got to tighten up.
So it would also indicate like if you had a leak somewhere in the system as well.
Yeah.
If you just
What we don't do on F-gas is the back rise test. There's no requirement. That rise test, we just leave it on, leave it for 5 minutes and see what it rises. You know, if it shoots right up, it's an indication. One of two things. It could be moisture, or it could be a leak. One of the two. So if there's moisture in there boiling, it's like imagine steam filling up your kitchen. Yeah. That's going to boost your pressure again.
I think we do the rise test on our fridge and freezer boxes.
You do. I know the MOD, they do like a 6-hour rise test or something like that. So remember, the MOD are going to take this to the next level. So I'm teaching you the minimum.
I just remember being sat down there, bored senseless because I forgot the book.